Toma ya. Toma ya. Oh, hey, please tell me that we are going to start. Come on. Hey, ROS developers, welcome to a new class, a new live class about ROS, the ROS Developers Live Class. I'm very happy to have you all here again today. It's the third in a row that we are going to dedicate this live class about mixing machine learning with ROS, with simulations of Gazebo. That's super interesting. About the class of today, what we are going to do is to apply TensorFlow. So we can use TensorFlow as a component that already works, and then we are going to integrate this with ROS. So what we are going to do is to take the camera images from a drone and capture the images, provide that to TensorFlow, and then TensorFlow will tell us if we are in front of a banana, of an apple, or whatever the objects that we are going to move around. Okay, so very good. So let's start. As you probably know, but if not, I'm going to repeat. What we are going to do in order to do this class is to use the ROS Development Studio. So you can practice at the same time as I'm explaining, okay? So these live classes are not about me just talking, showing some slides. It's about practice. 100% practice. So let's go for that. For that, we are going to use the ROS Development Studio. You need to have an account. If you don't have it, just create it now. But I don't know if you're going to be on time, okay? So don't worry. For the next, well, you can try. Maybe we'll be time enough. So once you have this ROS Development Studio account, then I'm going to share with you the notebook, the project with the simulation and the code and everything that we are going to use today here. And for that, well, I'm just going to go ahead. And so when I share this with you, it's going to be a link that I'm going to post there on the chat. And then you have to click. By clicking on that link, it automatically will copy the whole project that we are going to use today into your RDS account. And then you will have everything, and everyone will be ready to follow the class, okay? So I hope that this is clear. If not, use the chat to send me questions. You can send me questions now or during the whole class, in case that something doesn't work for you, something you don't understand, you can ask me questions, okay? Okay, so let's go then now. If there is no question, okay, Raul, hello, Rahul. Gianfranco, hello. Her hands, hello. Okay, so I see a lot of people of known names already, the usual suspects. Then let's go. Let me share my screen with you so you can see what I am doing with the computer. Okay, so here, sharing the screen. Then I am at the ROS Development Studio, and I'm going to share with you this project today is the ROS Developers Live Class 23. So what I'm going to do is to click here, and a new link is going to be generated. This is the link that I'm going to share with you. If you click on that link, the whole project here that I have will be copied to your user into the ROS Development Studio. Okay, so this link is too long for the chat, and then it cut it down. So what I'm going to do is to use the Google shortener and use this to shorten the URL. Then copy this link, shorten. And now this is the thing that I'm going to paste into the chat. Okay, so I can close this. I'm pasting this on the chat now. Maybe you cannot see it in the video because it's not shown, but you can see that on the chat. So there it is. The link is there. Hello, Joan Zhao, Tony, for the friends. And then, as I have explained, click on that link. By clicking on that link, it should automatically create the project and lead you to the ROS Development Studio page, where you will have the same thing as I have here, this project called ROS Developers Live Class 23. And with this image, and what we are going to do, if everything is okay, we are going to start opening the project. Okay, so I hope that all of you are with me now. You have clicked on the link. You have the project here in your ROS Development Studio area, private area. And now what we are going to do is to open the project. So please press here, open project, and you have some information about it, and just press open. And then after a few seconds, you should have the main screen of the ROS Development Studio. I hope that everything is okay. I see that nobody is complaining, so I suspect that everything is okay. Great. Let me know if you have any problem, okay? So I'm going to start now. So that was just a preparation before we start. And what we are going to do is to open the tools here, because we need to open the Jupyter notebook that we have prepared. Actually, it's a joint effort with Epson. He is the main creator of the notebook. So come here, so tools, Jupyter notebook. And then here, Live-Class 23. You click on there, and then this notebook will be open. And yeah, this is for the class 23. And as I mentioned, Epson Warco, he's one of the interns here in the Construct. And he is the main creator of this notebook. He's the one that shares the most of the credit for this. And then with the collaboration with Miguel Angel and myself, and that's the thing. So what are we going to do here today? So this is the third class in a row about applying machine learning to robotics. And the previous two ones were about using OpenAI, and this one is about TensorFlow. And so that's what we are going to do, is to continue. So you can have a look at later with more details. This is a medium level class and requires you to have some knowledge. And about this class, so if you have this notebook, you can watch afterwards the class here by selecting this cell here and pressing play. Then the video will appear here, so you can replay the whole class afterwards. Once everything has finished, and then you want to review the notebook and the class. Okay, so let's go to the proper material of the class. Then it's about how to classify images that contain objects by using the TensorFlow. And then we can use this for whatever the reason. In this case, we are going to use an R drone, a Parrot R drone. So it's a drone of the brand Parrot, and we are going to use the simulation. Then the drone is going to fly on one space and use the camera that has on the part of the bottom of the robot, and it's pointing towards the ground. And then it can see what is on the ground. So we are going to use this to detect the obstacles, the objects that are on the ground. So, okay, let's do the first thing that we are going to do is to launch the simulation. Let's start with the funny things. Let's launch a simulation. For that, this simulation is not contained here. If you open the IDE, you will see all the files of the project. Let me put it here. So in these files, okay, let me delete this zip file here. If you have this zip file, you can delete it because it's not needed anymore. Okay, so you can delete it. Then we have those workspaces. And then today, the notebook is stored here. So this is the notebook that you have opened. And then here, you have the Cat King workspace that contains any ROS code that we want to use. But here it's empty because today we have to build everything. And here in simulations, we should have the simulation that you would like to launch. But today it's empty. Why is so? Because we want to launch a simulation that is already provided by the ROS Development Studio, so you don't have to prepare any file. So it's easier. For those simulations, you can come here to the simulations menu and select the one about the drone that is here. It's Parrot AR drone. Select that one, and then the Gazebo simulation will appear here in another window. Okay, it's loading here. VentureRiff Tutorials, he just arrived. He says, hi, hello, VentureRiff. Welcome. And there are no comments there, so I suppose that everything is working for you. And here we have the simulation. Great. So where is the drone? Where is the drone? Cannot find the drone. The drone should be here, around here. Okay, it's not there. Okay, so it's not here, the drone. Let me see what is happening. Yeah, it should be here, the drone. Okay, so if you don't have it, that's very strange because it should be here. Let me see if it is invisible or something. No. And let me see if there is any error here in the log. Let me see. Wait, there is some in simulation. Then it looks like everything went correct. Okay, so I don't know what happened. So what I'm going to do is to launch it again. Okay, Parrot R drone. And that's it. And Diego is indicating that he has a drone inside. Yeah, that's a normal behavior. That's how it should be. So we have launched it hundreds of times, and I don't know what happened there. Well, you know, those things happen sometimes. But it's going to work now. Here it is, the drone. Yes. So let me know if somebody else doesn't see the drone. Okay, so there is the drone, and this is the environment. Okay, so we got it. Then let's go. The next thing that we have to do, that we are going to do, is to spawn the items of interest. These are the objects that we are going to try to recognize. Well, that's basically an example just of objects. Okay, so let's open a shell here in Tools, Shell, and then move this here, for example, and let's copy this launch file. It is a launch file. I'm going to type. So it's ROS launch. The models spawn library package, then spawn test objects dot launch. Okay, so yeah, so here it's doing the stuff. And it's inserting here. You will see that here it starts to appearing some of the objects, and you can see the objects are there. Great. So we have the object inserted here. I don't know what is the, oh, this is the can. And yeah, it's doing some strange things. Probably the initials are not correct or something. I don't know. And here we have, I don't know, something strange. The banana and the ball. Great. Okay, so now those are the objects that we are going to try to recognize while the robot is flying on top. Then what do we need to do is to put the robot start to fly it. So let's make it take off. For that, you have to publish in a topic of the simulation in the drone takeoff an empty message. So let's publish that empty message. It's already written there for us. So you can copy and paste. By publishing on that takeoff topic, the robot is going to start flying, as you can see. And there it is. So the robot is there flying. Great. Now, the next thing that you can do is to use the keyboard to control the robot, the drone. So let's use this program here. Let's launch this ROS program. That is the teleop to his keyboard. Let's use this to control the robot. So go to this shell and say and execute this command. By doing that, so you have here the keys that you can use to move the robot. And let me change the view so we can see better the robot moving. So remember that in order to move the robot, you have to have this shell in focus. Otherwise, the commands are not accepted by the robot. So I'm going to move it forward, then stop, rotate. Okay, stop, and then go backwards. Stop, and then go forwards. Okay, so you got it, yeah? You can also turn in autonomic mode. So you can press shift and then the command, and then it's going to turn to one side, but without rotating. So it's turning, but without rotating. Okay, so you got it. We have the whole system working. Okay, so that's the important thing. Another thing that I would like you to show is how we are going to see what the robot is seeing. For that, we are going to use the RQT image view. This is a program provided by ROS already that allows us to see what the robot is seeing on the cameras. So let's do that. Let's launch this command. Copy. First we'll need to use another shell because the shell is already taken by the keyboard. So we open here and then we launch that command of the RQT image view, RQT image view. Okay, let's launch it. Then this command generates a new window. And as you probably know, in the RDS, in the ROS Development Studio, in order to see the new windows, we need to open a special tool that is included here that is called the graphical tools. This is the one that is going to allow us to see the X windows generated by the programs. So select the graphical tools. If you get this message, just press login. And here we have the RQT image view. So let's press here to make it bigger, to cover the whole size. You can resize also. So let me resize so you can see better. And here in image view, let's select one of the topics that we would like to watch. So let's see, for example, the down camera. The down camera is the one that is pointing towards the ground. And the robot is now, okay, so the robot is has land. Okay, so let's move it up a little bit. Here it is, and then we can see on the camera. Let me stop it at that size. Okay, so we can see here what the camera is getting. Okay, and you can see there is something strange in this simulation that there is, now we can see here the tennis ball. Yeah, but also we are seeing here this line, white, that doesn't show on the simulation. So we found this while we were preparing this notebook. We didn't have time to figure out why is the reason. So this is a line that should be shown on the simulation, but it's not shown for whatever the reason, but it does exist. Okay, so now you have all the elements that we need in order to create our programs and for detecting and recognizing those objects. Okay, so let's go. We have a lot of work to do. So let's go. You can close all this. Close it because it's consuming some CPU. So, and we are not very rich on CPU here. So just close it. And yeah, we can close this. Well, we can leave the simulation. It's okay. And all the terminals, we'll use them later. Okay, let's go. Let's go to create the program. So here we have an explanation about what is TensorFlow. You can have a look at it. I'm not going to explain that because it's pointless. And I want you to prefer to use it. So in case that you want more information about the TensorFlow, it's here. You have in those links that we are providing here and here. Basically, what you need to know is that it's using deep learning to classify objects, to identify objects. And you can use that as a module that already works. And that's what we are going to do here. We are going to use it as something that is already made by somebody else, and we just use it. If you want to create your own models, your own trainings, etc., that's another matter, okay? Then you should look at those links. Or you can look at our course that I will give you more details. That we have a complete course at the Robot Ignite Academy. We have a complete course that teaches how to train your own recognizers with different objects, etc., and apply this to ROS. But that's another matter. Okay, so let's go. Then what we are going to do is to create first our package that is going to be the whole code that is going to work recognizing the objects and connecting to the TensorFlow. So let's use this command. Create a package, Catkin create package that you know, and let's call it like this. Please call it like that because otherwise we can have problems afterwards. It's not important, the name, but then the rest of the notebook, it may not work. So remember, we are creating ROS code. It's not something for the simulation. It's for ROS. It's for robots. Because of that, we had to go to the Catkin workspace/source. So let's go there. Catkin workspace/source using a shell. You are there. Now let's create the package. Catkin create package. You can copy there. I'm typing just to go a little bit slower so you can follow what I'm doing. If you get lost, please tell me something. Okay? So tell me that you have lost, you don't understand, or whatever your problem. Okay, so create package TF, unit 1 PKG. Then it depends on ROS-Pi, it depends on standard messages, and it depends on sensor messages. Okay. So, and as you can see, it appeared here in the Catkin workspace. Let me close those just to avoid confusion. So here it is, our package. And by default, it has created a source directory with nothing on it, of course. Okay, then let's create the TensorFlow files. And we are going to call it the image recognition.py. So you can come here to src. It can also be created on the script file, but let's put it here because it's already created. So add a new file and call it image recognition.py. And let's open it. Great, we got it there. And it's a little bit small, so I'm going to increase the size of the, well, actually there is no code there, but anyway. So let's go step by step on the different parts that this script has to contain, so you understand what is the structure. Okay, well, the first thing is the import, of course. So just copy this and here paste. Okay, so we need different things. First, ROS-Pi and the sensor messages of ROS. Then we need the CB because we are going to use OpenCV for the treatment, for the working of the images. And then finally, we are going to use, well, NumPy and then the TensorFlow related packages. Okay, so let's go there. We have that, and now we are going to create a class that we are going to call TensorFlow, and it's composed of 3 parts. Okay, let's go and copy this structure here, and then let's go step by step on each one of the parts. So this is the class that we are going to use for generating the whole recognition between the images that are captured by a ROS topic, and then pass this to the TensorFlow for recognition and produce a result into a topic. Okay, so what do we do in the init function? Well, then we have a present, we have a past, then let's populate this. Let's populate with this code here that we have. Is you can copy directly, Control-C, and then paste here. Remember how important it is, the indentation. So if you got the same problem as me, please select the proper indentation. Set the proper indentation there. Okay, so I don't know what is happening because it's too many reds. Oh, okay, now it recognized the proper indentation. Okay, so this is the init part. And what do we do? Well, the first, so here is the explanation that we have. Then we are calling to this method that is the one that is going to download the TensorFlow model if it doesn't exist. And then the first time that we execute this is going to take some time. Okay, and let me see. Yeah, because we don't have it here. Yeah, we deleted previously in order to start from 0. Okay, so we are going to call this in order to get that model. And this model is already prepared by TensorFlow, so we don't have to do anything. It's already trained. of course, we are going to use a model that is being trained with real stuff, and here we are using simulated stuff. So you will see some differences, but it works quite enough. So, okay, so you have here more information about what this model is able to recognize, but it can recognize a lot of objects. It's super big. This is massive. So this is the first function here. Then, of course, we create a connection to TF. That's it. And then, well, we create the CB bridge. The CB bridge is the bridge that we are going to use to convert the ROS images into OpenCV. Then the rest is that we subscribe to the image topic, and then we create a publisher where we are going to publish the result that we are doing, that we are recognizing. So it is a ball, it is a banana, it is whatever. Then also we have a couple of parameters. One is the score threshold. That is the one that allow us to indicate, so indicate how good we are of that recognition. So the higher the value of that score threshold, then the more sure we have to be in order to indicate that this is we have correctly recognized the banana, for example. And then the use stop key is well, it's a variable that is used in the classification results. We'll see below. Now, this is only for the initialization. Okay, so basically it's connection to the TF, getting the model, train model, connection to the TF, connection to the OpenCV, and then organizing the ROS parts that are going to be involved. Then the callback. Okay, so this callback is the callback that we have defined here in the image. So whenever we get an image, a new image from the topic image, from ROS, from a ROS topic, we are going to call this callback. That is this callback here. Okay, what does it do, this callback? Let's go step by step. Let's copy the code of the callback and put it here. Again, I have the problem with the indentation. Please be sure that you are selecting everything when you are applying the indentation. Okay, so now I have everything properly indented. If you don't get this aligned, then you will get errors in the execution. Okay, in this case, for example, we don't need to be aligned here because it's another level of indentation. But this level has to be respected in the same way as here. Okay, so what do we do here? And first, we get the image message is the message that contains the image detected by the ROS topic. And what we are doing is using the CB bridge to convert it into a CB image. Then, well, we encoded it into a JPG image and, well, and store, yeah, as a string. And we convert basically on a string. And then we are using the tensor. We are getting the tensor that we are going to use for doing the recognition. So you can use different types of tensors. You can think of tensors like different algorithms, maybe. So different algorithms that you are going to use for the recognition. So we are going to use this softmax. It's actually not a machine learning algorithm, but we can consider that here. So have a look at the documentation for more information about the possibilities that you have about that. And once we have that, then we create the predictions by calling just the session that we have with TensorFlow. And then we use the NumPy to convert into a single dimension array, because this is the predictions are returned in a multidimensional array. And we don't need that because it's a simple object recognition now. And then we use, in this case, is the let me see. Okay. So yeah, basically what we do is we, in this code here is very simple code of Python, that what we do is to get from the prediction, the one that gets the score, the highest score. And here is this score threshold parameter that we are comparing to. So from all the predictions, because the predictions can return several objects with different values of prediction, with different probabilities of being right on recognizing that object. So we use this loop here to get the one that has a score on top of the score threshold that we have defined. And then first, we print on the screen, and second, we publish the recognition. We publish on the topic that we have defined here on the result. Okay, so basically that's it. Is we get the image, convert into a proper format for the TensorFlow, we run the TensorFlow, and then we got the prediction and see if any of those predictions is above the threshold for proper recognition. Okay, so now let's go to the main function. And the main function, well, the only thing, that is a way of working, okay? So you can work in a different way, but it's basically this main, when we call it, it's just a spin. So the code is going to stay there until somebody press Ctrl+C whenever we call this function main. Okay, so this is a spinning forever here. A spin means that it's in this function, okay? Not calling the main all the time, just in this spin. And what this does is that it's waiting, basically it's waiting there without crashing this program. So it's waiting there until a new image is being received on the topic. Then when this is received, we go to the callback. The callback is here. Then we do the recognition, and then we publish the result. Basically, it's that loop all the time, while the main thread is stopped here. Okay, how do we activate this main thread? Because here we only have created a class. So, well, see, if you know Python, then we need a main then. That generates an instance of that class that we have generated. And that's exactly what we have here. It's the creation of the main. So you can copy this and paste it here, and be sure that the if is started at the beginning, really beginning of the indentation. So it's at the same level of the class. Why? Because this code is outside the class. This is the main. So when we call this function, this Python code, sorry, it will come here, main. What is doing here? Well, he is doing some classify. Let me see. Okay, so yeah, so it's doing some setup of the arguments, and then creating the node, and finally creating our class. Our class here, that is here. And finally, it's calling the main. So this is calling this main here and staying here. So the main will create an instance of this and get to the main and stay there in the spin forever. By creating this instance, it is automatically activating the init code that creates the subscriber, the publisher, and it starts this thread that is activating the callback every time a new image is received. Okay, so I hope that this works properly, that you can follow that code. Is actually quite simple, isn't it? So it's just that. And then let's save it. Okay, select this and save it. Okay, so what else? Okay, so we need to create this classify image here that we are importing here. And what is that? So, well, this is the code that it's actually doing all it's called the heavy lifting of the downloaded model that we have. And you can get this classify image, the one that we are presenting here, we have obtained here from the GitHub repo directly. but we are providing this here directly from, so you can copy and paste, and that's what we are going to do. So we need to create a new classify image here, file in the directory of the source here. Come here to the source and create a new file. In this new file, call it classify image.py. And once you have that, then you can select the whole code here. Okay, let's create this. Let's select everything. Actually, you can select the cell and press Control A, and everything will be selected. And then Control C. So you copy, come here to image classify image, open it, and then paste it. So you got there the whole code. Okay, so this is the one that is actually doing the work of the recognition and interacting with the TensorFlow. So thanks that it's already working. So we only can use it as it is. Okay, so let's not concentrate now on that. And okay, so what else? So we have here the data URL. Let me see. Where is the data URL? Here. Okay. Yes. So here we have the data URL. That it's a tar file with some of the models. Let me see. So, basically, that's the one that contains the model, and we are going to download it as we have seen here in this classify image, maybe download and extract. So that's the file that we are going to download and extract. So that's it. No need to explain anymore. Then finally, let's create the launch files that we are going to use to launch the whole code. Then first, let's create one launch file to launch this code. Then here in the package, create another directory, another folder that which you should call it launch, mandatory, and create a new file inside new file. And we are going to call it start underscore image underscore recognition dot launch. Okay, so open that file and then copy this code here. Copy and paste. What does it do, this code here? Let me just put it a little bit bigger so you can see everything and save it. I'm going to select here in text, I'm going to select the option of XML so we can see better. Okay. The colors, it's syntax highlighting. So what do we have here? Well, we are just creating a launch and launching our node, the one that we have created here, the package that we have created and the Python file that we have created. And the only thing that we are doing is to remap the image topic to the one that we provide as an argument to this file. Okay, so when we call this launch file, we can provide an argument with this name, RGB image topic, that is the topic that we want to use on the robot to capture the images and provide that for recognition. So we are going to use the down camera, but you can use that the same for the front camera or for any other camera that you add to the robot. Then that's why we are putting this argument. So we can, at launch time, we can decide which topic. Then by default, it's taking the drawn down camera image row. That is the one that we have observed previously. So we don't have to do anything, but this is very professional. way of working, because the code, the topic is called image as a general topic. And here we are allowing to be used with any topic in any robot. Okay, so basically that's it, no more. What else? Yeah, well, we have created a special file for launching the objects that we actually want to launch. And we can create that also, yes. Actually, we have already launched them, but spawn it. So I don't know if it's going to be a good idea in this case, but anyway, let's create it. So let's create it here, another launch file that is going to, a new file that is going to be called spawn test objects, spawn underscore test underscore objects dot launch. And when you open this one, copy this code here that is spawning a cup, a Coke, a watermelon, tennis ball, and banana. So select this cell and Control A, Control C to copy, and then paste here. So we also have this file. Remember to save all the files that we are creating, okay? So I'm not saying that, but I expect that you are doing this. So I don't know if we are going to use that because it's already there. And the drone, where it went. Okay, so it has a drift and then it's going up and up and as little by little. Okay, don't worry. We'll make it land afterwards. Great, so we are almost done. So this is for spawning the test objects. So that is our file. But we are not going to do this one because we have already spawned all the objects. So it's there. Then start the interface to start the drone. We are not going to do this because we already have done it and the robot is flying already. We have to launch the keyboard control. We are not going to do that because we already launched it. It's here in this screen. So that's great that we have a lot of work already done. And what about the camera feed? Yes, that would be interesting to launch again, because it's important that we see what is seen so we can check if we are going properly, moving correctly or not. So let's launch again this RQT image view. I'm going to use the same screen, the same shell that I used it previously. So this one, and launch it. Now, remember again, this window is an X window, so it's not a web window here. So in order to see this, I need to go back to the developers tools that is here. So I closed it previously, graphical tools, sorry. It's in the menu of tools, here, graphical tools. And here we should have it. And there it is. Okay, so that's what the robot is seeing at present. Okay. Okay, so we have this. Now, what else? Then now it's time to start our program, of course. That's the most important part. So let's go. Let's open a new shell. Open a new shell and put it here. And then let's launch our package. ROS launch EF underscore unit 1 package start image recognition launch. Okay, yeah, so you have this problem probably as me. Then let's go. This means that the image recognition.py doesn't have execution permissions. So let's go to this file and change the permission. How do we go? ROS cd EF unit 1 package src. Okay, once there, you can change this by do a ch mode space plus x, and then the name of the file. Ch mode plus x, the name of the file that we want to provide execution permissions. Now, if I do an ls, you can see that now it has changed to green. It means executable. If you do an ll, you will see the permissions, the x permissions here. That means that it is executable. Okay, so now we can retry. Let's launch it again. ROS launch, DF unit, package, start image recognition launch. Okay, let's go. And let's see if it works. Okay, so far is running. Then, as I mentioned, it may take some time while the system is downloading the model. Okay, so let's do, in the meantime, I'm going to put it here. In the meantime, I'm going to move the robot down. So I'm going to use this to make it go down with the B. So now you can see in real time how the image is getting closer and closer. Imagine that with a real drone. That should be amazing. Remember that you can use this code that we are developing here with a simulator with with a real drone. So you can do it. Okay, we are getting almost there. I have stopped it. Still, I cannot. Oh, yeah, and my model is already have started to indicate things that is seen. So let's see. I'm getting closer. Let me stop. Remember, to go up and down, you can use T up, B down, and then use K to stop. Okay, he says that there is a tennis ball, not a tennis ball. So the tennis ball, it has cleared the tennis ball. Okay, so by doing like this, we can see better. Okay, great. So it's recognizing the tennis ball somehow. And here in the simulation, where is my drone? Wow, it's super high. Okay, so let me get it down a little bit more so we can get a specific recognition. But as you can see, the algorithm is doing again, is recognizing in a non-stop. And also it generates a list of possible objects that are in the scene, if there are several. So it's not just recognizing one, but all the objects in the scene. Okay, so yeah, that's a little bit tricky to move. Remember that you have to have the focus on the control of the drone window. Okay, so now that I have it here, wow, that's this difficult. So let's change the perspective here. So okay, so we are like this, and then we can control better the drone. So try to control the drone and let me know if it is working with you. So you have to get the focus. Remember that, okay? So let's move a little bit down. Okay, and then let's move a little bit forward. Here is the banana and the tennis ball. Then the tennis ball, it's no problem. It's like very high, but the banana is not recognizing it very well. It recognizes a croquet ball. Yeah. Okay, so not good. Okay. It's a croquet ball and a tennis ball, it's saying. Okay, so let's move forward. Let's see if it can recognize, for example, the Coke. Here is a Coke. Okay, so tennis ball. Why is that in the image, the tennis ball? No. Okay, pool table, golf ball, cardigan. Well, as you can see, when it says all that, the score that is obtaining is very, very small. As you can see, it's very, very low. So you can filter all that by changing the parameters that we have used on these for these values. And let me see. So the robot is still moving up. And then I think that that's almost there. Yeah, that's all. So what I would suggest is that you play with these parameters here. in the image recognition. So you change this value of this core threshold that, as you can see, is very low. It's very small. So this is the default one. Okay, so you can use it. For example, let's put it bigger. Let's put it like 0.8. So it's not going to say so many stupid things. Then we need to stop the program and launch it again. Where was my shell? Here. Yes. So you need to close it and launch it again. And by doing this, then it will start again with this new value for the threshold. So I have put a very high threshold for identification, so it's not going to say anything about it. So let me move down. Okay, let's press down. So how are you doing, people? You are saying nothing. I don't know if you are very concentrated. What is happening there? So let me know if you have any question. I'm going to go down a little bit more to get closer to the objects and move around. So in this case, snooker, pool table, billiard table. Okay, so yeah, maybe it's here there are so many things that in the play. So during the test we got better results actually, but I don't know. So here, one of the things is that remember that this is a simulation, and also remember that we are very high. So, okay, the tennis ball has it clear that is there. That's a tennis ball. That's correct. And so we are very far from the object. So we should get a point where we get closer without crashing against the yes. So tennis ball, yes. Let me see if I can get closer. No, wait. It's getting too much. Okay, so, and I landed. Okay, so you practice with this. Okay, Diego says, it works well, Ricardo, but the air drone is sometimes not behaving as expected to my control input. Why is that? You have to take into account, that's strange. It should work, Diego, because here what happens is that you have to get the focus of the window that contains it. And remember that this doesn't mean that has the window. You have the focus. You have to have this also in white. Now it means that you have the focus. That's it. Okay, so if you want to learn more about that, I would recommend you our ROS Deep Learning with TensorFlow course. So in this course, you are going to get more things about, this is just a small introduction of the course, and it's some of the material that we are covering here in this chapter. But you have another one about how to use the tensor board to explore the trainings, how to train your own TensorFlow, and also how to use this to create a garbage collector robot. So I recommend you that you have a look at that. And also the OpenAI Gym for Robotics course that is also there, that contains a lot of details that like the ones that we have already talked on the previous classes. And this is at the Robotic Night Academy. And if you want, I have added this special 15% discount that is valid until tomorrow only. So you can get, if you apply this coupon, then you can get a 15% discount. But this is valid until tomorrow, okay? So hurry up on that. And finally, let me tell you about the ROS Developers Conference. That is the conference that we are preparing for in July now, in 2+ weeks, about with experts that are going to teach you how to do things in ROS in the same way as you are doing here with me for the class. and some of the speakers are already here. So we are going to talk about localization and navigation, how to use ROS to teach to undergraduate students, ROS Link, and here is a tutorial that still is missing. That's on day 1. And day 2, we are going to use an interesting architecture for controlling ROS humanoid robots. And well, and more things interesting like semantic knowledge and how to use a robot to do a warehouse inventory, and a special class on OpenAI, Gazebo, and ROS. Also, so have a look at that. And basically, that's all for today. And let me share with you something special that I would like to share with you, because it's the code that one of the attendants to the live class has created. Let me come here back. So Yuan Yao, that is one of the people that usually attends to the class, he was playing with the carpool problem 2 weeks ago, the live class of 2 weeks ago, and he kind of solved it, and he has provided us the solution here. And as you can see, I'm going to open the project. So wait, I have the previous one. Let me save the previous one, because otherwise I'm going to lose my work. So I'm going to save. And once it's saved, I'm going to open the other one, and I'm going to share with you the link to his project that contains the solution to the carpool problem, one of the solutions. Okay, that's saved. Then let's go again to the projects page, and let me open this one, the open project of the ROS Development Studio. And no, let me open here the Jupyter Notebook. This, I'm going to share this with you in a minute, okay? So basically, this is the same notebook that you got on the class 21, but at the end, Yuan Zhao, he has included this part about how he changed the code. Wait here, yeah, about the training. He is the author here, and how he achieved to get some reward and make the robot learn. Okay, so you can get here all the steps. It's very interesting, and it's clear. It's very clear. Reducing the running step. We are out of time, so I cannot explain that to you, but you can get it. And finally, you have a video that he has created here that you can activate. And in this video, you can see how his carpool is kind of learning a little bit. You see? Okay, so I will leave that for you to watch it. And this is the evolution of his score, of his reward. So let me go back quickly here. I'm going to leave, and I'm going to share this link, also this project, with all the attendants, so you can have Yuan Zhao solution. I'm going to put it here, shorten the URL, copy, and paste it here. So you have it there, okay? So then Diego is asking, is it possible to restore the R-drone position without closing the simulation? Yes, it is. So you can call a service that is called, what's the name of the service? Let me see. So I never remember, so I always have to check, but let me open it. There is a service that is provided by Gazebo, and it's a ROS service. And you can call this service to restart the simulation. Let me give you the exact name. So you can do a ROS service list, and you will get the names of all the services, and it's is reset. Okay, now I don't remember the differences between reset wall and reset simulation. I think it's reset wall, but I'm not sure. ROS service wall reset, so / Gazebo reset wall. Then the message is an empty message. So you have seen that it has blinked. So if we put it there, I presume that is this one, yeah, because it makes sense. So that's it. So you should set wall, and then you can get it. without closing the simulation. So that's the answer. Any other question, guys? We are about to finish now here. And so I'm waiting for your questions there. In the meantime, let me tell you that for the next week, we are going to work on how to create markers for RBIS. So we are going to start with the machine learning series, and we are going to start with new topics now. So now it's the next class. It's how to create your own type of markers for showing them on RBIS. You know, RBIS, the super useful tool for debugging the code. Okay, so that's the next class. If you want any other subject, please write it down on the comments, and we'll take care of that, and we will really prepare classes for your suggestions, because it's we want suggestions, because we want to provide you the material that you would like to learn. And basically that's it. So if you like it, please give us a thumbs up. That's something that is very important for us, because it provides the feedback that you are liking the classes, and then we are eager to get more. And of course, subscribe to our channel. We are publishing one new video teaching you something every day from Monday to Sunday. That's amazing, guys. Okay, so then okay, so Clapcop, he says that, can you do an Ask Me Anything series every month? Okay, yeah, no, we have stopped doing that, but you can send us your questions and we can put them on the class, or create a whole new class for your questions. The problem is that we didn't have enough questions. So either very small or either very complex questions. So it was very difficult to generate a class on that. It required a lot of work. That's it. Okay, guys, so we are going to stop here. If you have more questions, put it beneath the comments, and we'll answer them. Thank you very much. In the meantime, I'm going to continue practicing for kinematics. You know, I'm learning some kinematics of my own body. So see you. Bye-bye. Bye-bye.